Today we're going to be looking at section 4.4, part 1. And the first part of this is just all about factoring. So we're going to be looking at how can we completely factor a polynomial. And the way that we know we have the polynomial factored completely is when the polynomial is written as a product of polynomials, none of which are factorable. So none of which are factorable. Factoring by grouping, we're going to be using this when we have pairs of terms that have a common monomial factor. So we'll get to that here in just a minute. The other thing we're going to be looking at is quadratic form. We're going to have quadratic form when it's in this form, but it's not truly an x. It might be like an x minus 1 or something like that. All right, so let's look at some problems here. Sum and difference of two cubes. This is a type of factoring you probably haven't done. If we have a cubed plus b cubed, that's going to factor down into a plus b, and we're going to have a squared minus ab plus b squared. Looking at this example here, a is always going to be the cube root of this first term. So what is a going to be in this case? Do you know the cube root is 64? So it's going to be 4x. b is going to be the cube root of this term. What's the cube root of 1? So now we just follow the pattern. It's going to go a plus b, and then I have to square the a. I have to square that whole thing. That's how they got the 16x squared. Then it's minus a times b, which is just 4x, and then plus b squared. With subtraction, it's the same type of thing. The only difference is with the signs. So with this first one, it always matches the beginning. Same thing here. When it's subtraction, it matches the beginning. But then the second sign is always the opposite of the first. And then on both of them, the last term is always positive. Here's a formula you can use that would work for both of them always. A cubed plus or minus b cubed, it's always going to be a plus or minus b, but then it goes a squared minus or plus ab and then plus b squared. Alright, let's try this one. Can you guys tell me what a would be? 10x. What's b going to be? 3. So now following our formula, it's going to go a plus b. What's a squared going to be? 100x squared, then minus, what's a times b? 30x, and then plus b squared. What's that going to be? 9. There we go. Alright, what about number 2? What's a going to be in this case? 2x. What's b going to be in this case? 5, not just 5y, but 5y squared. Good. And so now it's going to go a, match the sign, minus b. Then it's going to go a squared, which 2x squared is going to be 4x squared. We have to square that whole thing. The sign is always going to be the opposite, so it's plus. We have to do a times b. That's going to be 10xy squared. And then what do I get if I square the b? 25y to the 4th is correct. So that's how that would factor. Any question on factoring the sum or difference of cubes, Yuri? No. As long as we can take the cube root of this and the cube root of that, then it'll be factorable. Now, if they're not perfect cubes, then it couldn't be. Yeah. All right. Any other questions on that? Now, you got to check and make sure it's the sum or difference of cubes, because it could be the difference of squares, which would have a completely different formula to it. Riley? Okay, let's go over to the next page now. We're going to look at how we completely factor these. Alright, let's look at number 2. We're actually going to start with number 2 here. The first thing that you should always look for when you're factoring is the greatest common factor. Is there a value that m to the 5th and 81m can both be divided by? M, right? So I'm going to take out an m. M to the 5th divided by m is m to the 4th minus 81m divided by m is just 81. I have to see now that this can be factored further. The reason it can be factored further is it's the difference of two squares. The difference of two squares. And so then to square this, to factor this further, this is going to go down into m squared and m squared, and 9 and 9, and plus and minus, addition and subtraction. See, look guys, if I check this, m squared times m squared is m to the 4th. The outers give us negative 9m squared. The inners give us positive 9m squared. Do you guys see how that would work? And then positive 9 times negative 9 is negative 81. Right? Now we have to check and see if we're finished. Can any of these be factored further?
Wouldn't the m squared minus 9 and 6 can be factored further?
Yes. So this stays the same, this stays the same, but this again is the difference of two squares. How does it factor down then, Amelia?
I forget.
Can somebody help her? Ian? Right. And that only works if it's the difference of two squares. The sum of two squares doesn't factor down any further into real values. And so this would be the completely factored form. Alright, I want you guys now to try number 3. Try number 3 on your own. And when you've got it, just raise your hand real quick, and then you can put it down. Be pretty close to having it. Shreya, do you have it? Not quite. Allison, do you have it?
Yeah.
What did you get?
I got 3x squared plus 2, and then 9x squared minus 6ab minus 4b squared.
You got it. Very good. Plus though. On the last one it's always plus.
I got 24ab.
Nope, it's just a times b, so 3a times 2b is 6ab.
Okay.
Alright, this is it. Okay, let's look at the next one now, number 4. This is going to be a different type. I don't know if you guys did this in Algebra 1, but it's called factoring by grouping. When we see 4 terms, we're going to try grouping them into 2 and 2. And we're going to look for GCFs. Out of these first 2, I can see that I could factor out a t to the 5th. 5t to the 6th divided by t to the 5th is 5t. 2t to the 5th divided by t to the 5th is just 2. Whenever I have a subtraction symbol here, I have to factor out a negative. So I'm going to have to factor out a negative, and then I look at this. T to the fourth, t to the third. I can factor out a t to the third. And now I look at what I have left. Negative 5t to the fourth divided by negative t cubed is going to be positive 5t. Negative 2t to the third divided by negative t cubed is plus 2. Now I look at these two. Do you see how they have a 5t plus 2 in common?
Yeah.
So I can factor a 5t plus 2 out of those. If I factor a 5t plus 2 out of this term, I'm left with t to the fifth. Minus, if I factor a 5t plus 2 out of this term, I'm left with t cubed. Now, there's something I forgot to look for at the very beginning, and that was a GCF for the whole thing. But that's okay, because I can do it now. What is the greatest common factor for these two right here? T to the third. So I'm going to go ahead and take a t to the third out of there. If I factor that out, t to the fifth divided by t third is t squared. Minus t to the third divided by t to the third is 1. I'm getting closer. What about this though? Can this be factored down further? Yeah, it can. So now I'm going to have my final answer. T cubed times 5t plus 2 times t minus 1 t plus 1. And that's going to be my final completely factored form. I did rearrange it a little bit. I put the t cubed first because it was a monomial. Then I put this one. And then when I factored this one, I got that. Alright, that's probably one of the more difficult ones you would see. If I had thought to factor out the t cubed at the very beginning, which I should have, it would have been a little bit easier to do. Alright, let's look at the next one here, number 5. I look and I see whether or not I have a greatest common factor, and I don't. So I set up my double parentheses. What times what would give me y to the fourth? So I'm going to have y squared times y squared. Now I look here. What are numbers that multiply to be 48 and subtract to be 13? 6 and 8 doesn't work. 16 and 3. So I'm going to use 16 and 3. I check the outers, that gives me 3y squared. The inners give me 16y squared. I want to get a negative 13y squared. So I'm going to have the 16 negative and the 3 positive. Can we do more? Yep, so let's keep going. So it's going to be y plus 4, y minus 4 times y squared plus 3. Alright, let's do just a couple more. I don't think we need to do all of these, but let's go ahead and do another factoring by grouping. On this one, I'm going to group it 2 and 2. What can I factor out of the first two? 5t. And I would be left with p squared plus 1. What am I going to have to factor out of the second two? Negative 7. You have to take out the negative. So that's going to give me p squared plus 1. Now I have, this is one term and this is the other term. And what do those two terms have in common? So I have p squared plus 1. When I take this term and divide it, I'm left with 5p. When I take this term and divide it, I'm left with minus 7. Did you guys do factoring by grouping in Algebra 1? Yeah? Okay. All right. Any other questions on that? Okay, we're just going to do one more together, and then I'm going to ask you to do one on your own. Let's go ahead and look at number 9. This problem would be really difficult if I don't look for that greatest common factor first. So what is it that this, and this can all be divided by? So I'm going to take out 2x to the 4th. So when I divide that out, I'm left with x squared. Divide that out, I'm left with minus 4x. Divide this, and I'm left with minus 21. To see if this can factor further, I look right here, and I say, are there numbers that will multiply to be 21 and subtract to be 4? So we set up our double parentheses, x and x. We know it's 7 and 3. With the inners, we have a 7x and a 3x. We need to get the negative 4, so it would be like that. All right, I'm going to have you guys try just 2 on your own. Let's have you guys try 10 and 12 on your own. I know some of you aren't quite finished, but I want to hear what people got, and then you can keep working. Riley, do you have number 10?
Yeah. I got 5c squared minus 6 and 2c.
You guys agree with that? Anybody confirm that answer? That's correct. Austin, did you get number 12?
I think.
What do you have?
X times 4 squared minus 4x plus 1.
I agree, but I think it can be factored further. Here's how I check, just real quick to remind you. I multiply 4 times 1 and I get 4. Are there factors of 4 that I can combine to get negative 4 when I add them? Yeah. Because what are the numbers that would multiply to be 4 and would add to give me negative 4? Negative 2 and negative 2. So when that happens, I know this can be factored further. So what do you have, Lauren, for your final answer?
X times negative 2 plus 1 squared.
Say it one more time. X times
Negative 2 plus 1 squared.
negative 2 plus 2x squared?
Long.
Yeah, that's not quite it, actually. Allison, what do you have?
I got it.
Hold on. I asked Allison. Go ahead.
I have x and then 2x minus 1 squared.
Yeah, that's going to do it, right? Okay, and that's because when we have this, we're going to set up our double parentheses. We say 2x and 2x. Numbers that multiply to be 1 are 1 and 1. I need to get a negative 4, so negative and negative, and then this would be the best way to write that. Okay? Easy enough? All right.